Alright, so in this problem, I have 4 to the power of x is equal to 40. So to solve this, I'm going to start by taking the log on both sides. So now I have log of 4 to the power of x is equal to log of 40. Now, if I have something in the form log of a to the power of b, I can move this exponent of b to the front. So this is going to equal b times log a. So in this case, I have log 4 to the power of x, and I can move x to the front. So now I'm going to have x times log 4 is equal to log 40. Now I'm going to go ahead and divide both sides by log 4 so we can isolate x. So then these two log 4's cancel out, and I'm going to be left with x is equal to log 40 over log 4. Now we can rewrite log 40 as log of 4 times 10. And if I have something in the form log of a times b, this is equal to log a plus log of b. So log 4 times 10, that's going to equal log of 4 plus log of 10 over log 4. And if you guys already know, log 10, that's actually equal to 1. So I have x is equal to log 4 plus 1 over log 4. Now, I can rewrite this as log 4 over log 4 plus 1 over log 4. Now log 4 and log 4, these two cancel out. So I have x is equal to 1 plus 1 over log 4. Now log 4, this is equal to 0.602. So I get x is equal to 1 plus 1 over 0.602. And 1 divided by 0.602 is 1.66. So 1 plus 1.66 is 2.66. Alright, so in this problem, I have x to the power of 2 minus x to the power of 3 is equal to 12. So I'm going to first start by rewriting this as negative x to the power of 3 plus x to the power of 2 is equal to 12. And from here, I'm going to multiply both sides by negative 1. So now I get x to the power of 3 minus x to the power of 2 is equal to negative 12. And now, finally, I can add 12 on both sides. So now I get x to the power of 3 minus x to the power of 2 plus 12 is equal to 0. Now I'm going to rewrite 12 as 8 plus 4. And I'm going to actually move some terms around. I'm going to move 8 next to 8 to the power of 3. So if x to the power of 3 plus 8 minus x squared plus 4 is equal to 0. And 8 is the same thing as 2 to the power of 3. 4 is the same thing as 2 squared. If I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. And a squared plus b squared is equal to, a squared minus b squared is equal to a plus b times a minus b. So in this case, I get x plus 2 times x squared minus 2x plus 4 minus x plus 2 times x minus 2 is equal to 0. From here, I can factor out x plus 2. So I get x plus 2 times x squared minus 2x plus 4 minus x plus 2 is equal to 0. And if I simplify this, I get x plus 2 times x squared minus 3x plus 2 is equal to 0. Sorry, minus 3x plus 6 is equal to 0. Now, I get two equations from this. I get x plus 2 is equal to 0, and I get x squared minus 3x plus 6 is equal to 0. So for x plus 2 equals 0, x is obviously equal to negative 2. And for x squared minus 3x plus 6 equals 0, you have to use the quadratic formula. And I'm not going to waste your guys' time by actually plugging these into the quadratic formula, but the final answer is that it's actually going to be rejected because the square root is going to be negative, and you can't take the negative of square root. So my only answer is x equals negative 2. Alright, so in this problem, I have 25 to the power of x minus 15 to the power of x is equal to 9 to the power of x. So I'm going to first start by dividing all my terms here with 9 to the power of x. So now I have 25 over 9 to the power of x minus 15 over 9 to the power of x is equal to 1. 9 to the power of x over 9 to the power of x equals 1. Now I'm going to rewrite 25 over 9 as 5 squared over 3 squared to the power of x minus 15 over 9. That's just simply equal to 5 over 3 to the power of x, and this is equal to 1. Now 5 squared over 3 squared, that's equal to 5 over 3 squared. So I have 5 over 3 squared to the power of x minus 5 over 3 to the power of x is equal to 1. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 5 over 3 to the power of 2 to the power of x, that's going to equal 5 over 3 to the power of x to the power of 2. Now I have this minus 5 over 3 to the power of x is equal to 1. Now I'm going to let 5 over 3 to the power of x equal to the variable y. So now I have y squared minus y is equal to 1. And if I subtract 1 on both sides, these two cancel out, and I get y squared minus y minus 1 is equal to 0. So now to solve this, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I have negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times negative 1. And this is equal to 1 plus or minus the square root of 1 plus 4 over negative 2, which is equal to 1 plus or minus the square root of 5 over negative 2. I'm sorry, this will actually be just a regular 2. So now that I have my value for y, remember how I said 5 over 3 to the power of x equals y. So now I have 5 over 3 to the power of x is equal to 1 plus or minus the square root of 5 over 2. So now if I take the log on both sides, I get log 5 over 3 to the power of x is equal to log 1 plus or minus the square root of 5 over 2. And now I can move x to the front. So now I have x times log 5 over 3. If I divide both sides by log 5 over 3, I get log 1 plus or minus square root of 5 over 2 over log 5 over 3.